Hello. In this lesson, you'll learn about arithmetic and geometric sequences in series. First, some notation. A sub 1 stands for the first term. D stands for the common difference in an arithmetic sequence. R stands for the common ratio in a geometric sequence. You can find D by taking the second term minus the first term. You can find R by taking the second term divided by the first term. These also need to be equal to D being the third term minus the second, or R being the third term divided by the second. A sub n is going to represent the nth term in a sequence, and S sub n is going to represent the sum of the first n terms. Here are some useful formulas for both arithmetic and geometric sequences and series. First, for sequences, to find the nth term. In arithmetic, we would take a sub n. It's going to be equal to a sub 1 plus n minus 1 times d. So if you know the first term, the common difference, and the number of terms you're interested in, you can find a sub n. Matter of fact, this formula can be used anyway as long as you know 3 of the 4 quantities. Geometric, the nth term is going to equal the first term times r to the n minus 1. Again, here we have a geometric sequence, and there are 4 variables. As long as we know 3 of the 4, we can find our unknown. Sometimes we'll be finding the 10th term, and then sometimes we'll be identifying 102 is what term if the first term is 1 1/2 and r is 3/2. We can also find the sum of the first n terms in a series for an arithmetic series. It's S of n equals n divided by 2 times the quantity a1 plus a sub n. So basically the first term and the last term in this series. Here's an alternative form. You can find the sum of the first n terms by taking 1/2 times 2 times a plus n minus 1 multiplied by d. For a geometric series, the sum of the first n terms is going to equal 1 minus r to the n divided by 1 minus r. This is the formula for the sum of a finite geometric series. Later, you'll learn a formula for the sum of an infinite, never-ending list of numbers that are geometric. All right, so let's take a look at a question. You are considering a job, but the pay plan is a bit different. On your first day, you will be paid $5. Each day following will receive a payment of $1 more than the previous day. So on day 2, you will receive $6. On day 3, you would receive $7. This pattern will continue until the last work day. How much would you be paid, pardon my spelling, on the final day? What would be your total pay for the year? So looking at our problem, we know that the first term is 5. We know the common difference is 1, so it's an arithmetic sequence and series. And there are 49 weeks of 5 days working. That's 245 total pay days we'll get, 245 pays. So we're wanting to know how much do we get on the 245th day? And what's the sum of the first 245 days? So our 245th day is going to equal the first day plus n minus 1, 245 minus 1 times our common difference of d. On your last day of work, you'll receive $249 for that particular day's work. The sum of the first 245 days is n over 2, 245 over 2, times the sum of the first day, 5, plus the last day, 245. So for those 245 days for that year, you'll earn a total of $30,625. This is just an example using arithmetic sequences and series. Geometric sequences and series would work the same way. We just have different formulas for a sub n and s sub n.